down here, okay? Just kind of keep that in mind as you're watching the slides. Well, let's think about this too. If the moon comes back towards the Earth and the force of gravity gets ever larger, well, what's it going to do? Well, what is the major physical impact of the moon upon the Earth? It is tides, correct? Now, if the moon starts to come back towards the Earth, well, let's think about this. If the moon comes back towards the Earth, the tides would get higher and higher, correct? Right? Now, if you go back 1/2 billion years, and again, just on a laptop computer, well, the tides on Earth would rise 1 mile high twice a day. I think my first question would be, do you know how to breathe underwater? And keep in mind, if the tides rise 1 mile twice a day, just in your mind start thinking about erosion for just a minute, okay? Now, another argument that evolutionists use, supposing that the universe is, well, millions and billions of years old, they say it takes millions and billions of years for light to travel here from distant stars, distant galaxies. Is that correct? Now, I'd like to ask everybody a question. How many of you were taught, as I was, the speed of light is a constant? Come on, in school they taught us the speed of light is a constant, right? 186,000 miles a second, 300,000 kilometers a second. Is that correct? But how many of you know that's not true? The speed of light is not a constant. As a matter of fact, if you're looking for this material, I have it on my website in a free article you can just download. And I'm citing mostly evolutionary scientists. But the fact of the matter is, the speed of light is not a constant. You see, these are just some of the citations of work done in the last few years. But we've actually been able to measure the speed of light slowing down since 1675, when Romer made the first measurements of the speed of light in an accurate way. But research done in the last 10 years has been able to actually accelerate light, decelerate light, and even stop it and start it again. Now, if you can speed it up, slow it down, stop it, and start it again, would you agree with me it's not a constant? Is that right? Oh. Now, I will point out too here, the creation astronomer, Dr. Barry Sutterfield of Australia, using one method of scientific approach in astronomy, and Dr. Trotsky, who is from Nizhny Novgorod, Russia, which is my sort of headquarters in Russia. I always go to Russia twice a year. I've been there 28 times and so forth. But he is an atheist. But he's an astronomer working in Russia in Nizhny Novgorod. And Dr. Sutterfield working in Australia, one a creationist, one an evolutionist. And using two totally different methods of scientific proof, have come to the same conclusion. Both of them conclude that at one time recently, the speed of light may well have been 10 million times faster than today. Now, if the speed of light were 10 million times faster than today at some time in the recent past, I think that would drastically change your idea of how long it takes light to get here from distant objects. Is that correct? I think so too. And I'm sure you've all noticed that the galaxies are rotating too fast. Is that right? Come on, you had noticed, right? You hadn't noticed? Where are your powers of observation, people? Yeah. Now, not all galaxies rotate, but there are two kinds of galaxies specifically that do rotate. And when we take a look at these rotating galaxies, it doesn't matter how far across the universe we see, they're rotating too fast. Evolutionists call this the winding up dilemma. They've known about it for over 60 years. But it doesn't matter how far away we look in the universe, we see distinct spiral galaxies at great distances in every direction. Now, I want you to think about this for a second. When we see these spiral galaxies, we see clear spirals, we see individual stars at great distances, but these galaxies are rotating. Now, we can measure how fast they rotate. Now, if you think about it, if some of these galaxies were as old as evolutionists claim, they would be 100 to 200 turns since they were created or came into existence. But if they had turned 100 to 200 times, when we take a picture of them, they should just look like a smear on the photographic plate. But instead, we see them as distinct spirals with just 1, 2 turns perhaps at great distances. This tells you they haven't been rotating all that long. As a matter of fact, it limits the age of these galaxies to, at most, well, a few 100 million years old. Now, if the universe is less than a few 100 million years old, then the Earth must be less than a few 100 million years old. Is that correct? You all are watching the bouncing arrows, right? Okay, I'll do that one more time now. Okay, see, there's the bouncing arrow, and the age of the Earth gets younger, right? Well, let's continue. There's too much salt in the seas. I mentioned there's too much salt in the Dead Sea, but there's too much salt in the regular seas as well. Today, the oceans are approximately 3.5% salt content. Now, the total amount of salt in the oceans today would accumulate, at current rates of accumulation, between 42 and 62 million years. That makes the Earth's oceans less than 62 million years old, which of course would make the Earth younger. Is that right? And this is the Cape Hatteras Lighthouse, made famous in the United States. It's in North Carolina. It was built in 1870, one of the most historic lighthouses in the United States. When it was built in 1870, it was 1,500 feet from the water. Okay, so it was 1,500 feet from the ocean in 1870. In 1989, 116 years later, it was 160 feet from the ocean. I don't think the lighthouse moved. Well, actually it did. You see, in 1999, we moved it back 2,950 feet from the water to try to preserve it as a historic lighthouse. But even now, we think it may only preserve it for another 100 years. And let's think about this erosion problem. These are the White Cliffs of Dover, made famous in song and history. Now, evolutionists say that the White Cliffs of Dover are Cretaceous deposits made 65 million supposed years ago. Now, the White Cliffs of Dover are basically trillions of single-celled creatures called diatoms that are fossilized. It's actually what you make toothpaste out of. It is. That's the abrasive in toothpaste. Now, let's think about this. According to evolutionists, the White Cliffs of Dover are 65 million years old, correct? I don't think so. Think with me for just a moment. The continents are all eroding too fast for the Earth to be old. The cliffs of Dover, if they were eroding away at only 1/2 foot per year for 65 million years, well, that would be about 6,200 miles of coastline that would have to have been eroded westward through England. That's greater than the distance between, say, Tokyo and London. If you hadn't noticed, England's not that wide. And these are 5 photographs taken from 1986 to 2002 at Happisburgh, England. You can clearly see in this photography right here the erosion of the coast in only 16 years. Is that correct? And you can actually see it happen before your eyes. Is that right? As a matter of fact, think with me for a moment. Since the Roman times, 2,000 years ago, the English North Sea coast has eroded 2 miles west along the east coast of England. We know of 35 villages in the Roman census 2,000 years ago that have been completely lost into the sea. That's an average of 5 foot per year. Clearly that erosion rate, cannot have been going on for millions and millions of years. Is that right? There simply wouldn't be in England. And let's face it, if you erode off the land, you've got to erode into the oceans. Is that correct? I mean, you erode the mud off the land, it goes in the ocean. But there's not enough mud in the oceans. You see, when we take a look at the ocean floor, we have recently discovered a spot in the Pacific where there is no mud. It's exposed bedrock. But even being super generous, trying to find the greatest, thickest layer of mud anywhere on the ocean floor today, all of the mud would still accumulate in less than 12 million years. So that would make the Earth young. Is that right? And then, of course, this is the beautiful Cat's Eye Nebula. Now, a nebula is an exploded dead star. Now, some of them are beautiful, some of them are just downright ugly. But a nebula is an exploded dead star. Now, listen to me very, very carefully. In spite of anything you've seen on TV, radio, magazines, movies, or whatever, we have never, ever seen a star born. Did you hear me? We have never, ever seen a star born. If evolutionists were correct, then suppose it would take millions and millions of years for stars to be born. Now, have we been around that long? So we've never, ever seen a star born. You understand me? Another thing, too, think with me for just a moment. Now, I'll try to say this in the most diplomatic way I can think of, and I hope you'll agree it was. Tell me something. If you took one photograph of a human baby being born, Okay, so if you take one photograph of a human baby being born, and the photograph was taken in the middle of the birth canal, could you tell whether the baby was coming or going? No. Not based on one photograph, is that right? We have never, ever seen a star born. But we have seen stars die, and when they die, they explode, and they push out gas in millions and millions of miles, and what's left of the star illuminates behind the gas so we can see the gas. As I say, some are absolutely beautiful, some are just downright ugly. Now, here's the thing. There are too few supergalaxies in our galaxy, or in the universe, for that matter, for it to be old. Now, we can count them. One star dies about every 25 years per galaxy. So approximately one star dies per 25 years per galaxy. Now, evolutionists claim that the Milky Way galaxy, that's our galaxy, is 10 million years old. Here's the problem. We can only find 200 dead stars in the Milky Way galaxy. This indicates the age of our galaxy is less than 7,000 years old, or perfectly consistent with 6,000. But if evolutionists were telling the truth, there should be 400,000 dead stars in our galaxy, but there's only 200. And understand that we can see in other nearby galaxies like Andromeda, we can also see stars exploding and dying. And they occur 1 per 25 years per galaxy, but they're missing. It proves the whole thing is young. And I'm sure you've also noticed that the sun is rotating too fast, right? Come on, you've all noticed the sun is rotating too fast, right? Please do me a favor, don't go out and stare at it. But I want you to think about this. As the Earth and Moon are rotating, so is the sun. The sun is a huge ball of gas. It's 860,000 miles across. It's basically 430,000 miles in radius. It's a huge ball of gas, and it is rotating. Now, it is incorrect to believe that the sun is a huge fusion furnace that it's all burning up. That is not true. It isn't burning up. But there is a small fusion furnace in the center of the sun, which is, so to speak, burning up. Now, that fusion furnace in the center is producing particles which are trying to get out of the sun. So let's think about this. Particles are leaving the center of the sun, but as they're trying to get out, they get in the way of the particles coming around. Okay, so the particles are trying to come out, but they get in the way, hinder the particles rotating around, just as the tides on Earth slow the rotation of the Earth. So, the tides slow the Earth. Here, in this case, the particles coming out slow the rotation of the outer layers of the sun. This would eventually stop the outer rotation of the sun, but the sun is still rotating. And since the sun is still rotating, we know it has been rotating for a very short time. As a matter of fact, it's only been rotating for less than 1 million years. Now, if the sun has been rotating for less than 1 million years, that would make the Earth young. And there's too much dust in near space. It doesn't matter where we look in the solar system, between the planets, the moons, and so forth, there's too much dust. You see, 98% of the mass of the solar system is in the sun. It has tremendous gravitational force, but so do the planets and the moons. But there's too much dust, because if the solar system were millions and millions of years old, gravity of the sun and the planets, well, this gravity of the sun and the planets would all pull that dust in. It would sort of vacuum the solar system, and there wouldn't be any dust, but the amount of dust that we now know to exist limits the solar system to only a few thousand years old. Well, I think you'll admit that would make the Earth young. Is that correct? And then, of course, there's the decay of the Earth's magnetic field. In my personal opinion, the decay of the Earth's magnetic field is one of the single strongest arguments for a young Earth. As a matter of fact, it's irrefutable. There has never been a totally adequate explanation by evolutionists for this. We've been able to measure the decay of the Earth's magnetic field since the early 1800s. But it decays in the same way that a radioactive material decays. It has a half-life. That half-life is 1,400 years. So every 1,400 years, 1/2 of the strength of the magnetic field decays. Now, if you go back in time, it would double, right? So let's think about something. The Earth's magnetic field is tremendously important because the magnetic field of the Earth protects us from the deadly radiation that comes from the sun. The cosmic winds, the deadly radiation that comes from the sun is ionized. It comes and hits the Earth's magnetic field. The Earth's magnetic field bends it and comes in at the North Pole and the South Pole. It causes what's called the northern lights, the southern lights, the aurora borealis, the aurora australis. But this is deadly radiation streaming into the Earth's. Now, if we didn't have the Earth's magnetic field, that deadly radiation would come straight in and kill everything on the Earth. So the magnetic field of the Earth is tremendously important to us even being alive today. Now, it will be gone in about 2,000 years. This is one reason why I know scientifically that the Lord Jesus is coming back sometime fairly soon. Because I've read the book and there's going to be people here to meet him. And because of the decay of the Earth's magnetic field, the Earth isn't going to last for a whole lot longer. But if I go back in time and double the strength of the magnetic field every 1,400 years, well, 10,000 years ago, the strength of the field would kill all life on Earth. So if you go back to what would be 8,000 BC, the Earth's magnetic field would be so strong it would kill all life on Earth. Without it, the sun would kill all life on Earth, and it'll be gone in about 2,000 years. We live in a very narrow band of time. Think with me. Based on the strength of the Earth's magnetic field, all life would be dead 10,000 years ago. So if no life, no living organism could possibly exist on Earth even 10,000 years ago, if there had been a 10,000 years ago, then is it possible for evolution to have been occurring on the Earth for the last 1.5 to 4 billion supposed years? Well, no. Is that right? And it's not going to last a whole lot longer. I would like to make this statement to you. God never intended the Earth to last for a long time once it became, well, imperfect. It became imperfect because of human sin. Did you hear that? So God never intended the Earth to last for a long time once it became imperfect. Well, this limits the age of the Earth to less than 10,000 years and, of course, makes the Earth young. And then, of course, we have what are called short-period comets. Now, I'm sure many of you have seen comets in your lifetime. And comets are basically big, dirty ice balls. They're just big, dirty ice balls. They're just rock and ice. We've taken close-up pictures. We've sampled them and so forth. Now, comets go around the sun. They get very close to the sun. When they get close to the sun, they melt. So they lose about 3 to 5% of their mass every time they go by. So let's think about this. We have these comets that are called short-period comets. Now, almost all comets are short-period comets. There are a few long-period comets. Now, short-period comet means it has an orbit of 200 years or less. Now, let's think about this. We still have short-period comets in the solar system. They would all be gone in less than 10,000 years. So the fact that we still have short-period comets says that the solar system is less than 10,000 years old. Even the long-period comets would be gone within 100,000 years. Well, that makes the solar system and the Earth young. And then, of course, there's too much uranium in the oceans. You see, uranium is a salt in nature. It dissolves in water and will go into the oceans. But there's too much uranium in the Earth's oceans for the Earth's oceans to be billions of years old. As a matter of fact, it limits the age of the oceans to less than 10,000 years old. Well, that would make the Earth young. And then, of course, high-pressure natural gas and natural oil wells still exist on Earth. Not too long ago, I was in our state of Arkansas. There were hundreds and hundreds of natural gas wells. And in our state of Arkansas, they were still finding natural gas at pressures of 9,000 pounds per square inch. But around the world, we still find natural gas wells up to 20,000 pounds per square inch. Now think with me. You only find natural gas, natural oil, and natural coal between layers of dried out mud or some kind of sandstone. Now, sandstone has porosity. I mean, when you go down to the beach and you see the wave come in and hit the beach, well, the wave comes back into the water, but you also see the water go down in between the sand grains, correct? So sandstone has porosity, and gas can leak through a rock. You can actually push a gas through a rock if the rock is sedimentary. You give me any natural gas that occurs on Earth, any natural piece of sedimentary rock, give me any pressure you want to start at, I will take it into a laboratory and I will tell you how long it takes to push a gas through a rock. Because you can push it through a rock if it's sedimentary. Well, the problem is this. No natural gas or oil well we have ever found could be more than 100,000 years old, or the pressure would already have been released into the atmosphere, and that, of course, would make the Earth young. I've noticed these arrows are all stacking up on the right side. How about you? And there's not enough Stone Age skeletons. Now, if a skeleton is buried in the ground, Well, if it doesn't become fossilized, it will still decompose. The molecular bonds will break down, and over time the bone will actually turn to dust if it's not fossilized. Now here's the problem about Stone Age skeletons. Skeletons are said to last perhaps 200, 250,000 years before they're just dust in the ground. Assuming a Stone Age population of 1 to 10 million at any one time, and let's say the Stone Age supposedly produced people was 185,000 years, well, that would mean you'd have 8 billion burials. Please tell me, where is the evidence? Where are the artifacts? Where are the skeletons? We only find a few thousand skeletons in the ground. This actually proves that the earth is young, limits the Stone Age to a few hundred years. Well, that sounds biblical. What is the, quote, Stone Age, unquote? Well, let me ask you the first question. Has there ever been a time on earth when there was not a Stone Age? Did you hear that question? Has there ever been a time on earth when people didn't use stone tools? No, there's never been a time on earth when people didn't use stone. We still use stone tools today. Has there ever been a time on earth when there wasn't an iron age or a copper age? Well, think about it. According to the Bible, Tubal Cain, 3 generations from Adam, was smelting ores before the flood. Is that correct? And I just showed you pre-flood Bel. Is that correct? Well, the fact of the matter is, what they say, the Stone Age? The Stone Age is nothing but the people living in the area of the Middle East, leaving at the time of the Tower of Babel experience and migrating to Europe, living in caves for a couple of hundred years, which was a smart thing to do in Europe because I think you'll agree, you think of Neanderthals, Cro-Magnons and so forth, they're living in caves in Europe. Now that's a smart thing to do.